Everything we previously understood about Pluto, the planet beyond the solar system, has been completely altered by a recent display of wild fluctuation. When scientists explored Pluto, they found amazing features that had never been seen before in our solar system, unlike when it was previously thought to be an icy dwarf planet with little to no activity. It's amazing to know that we now have a deeper grasp of the world than ever before. Recent James Webb images that show planets in all their beauty have been made accessible by NASA, and they're simply outstanding, to put it mildly. What unforeseen discovery on Pluto was made by the James Webb telescope? Could it be a hub for extraterrestrial activity? Join us as we explore the James Webb Space Telescope's terrifying new discovery on Pluto that changes everything. Previously regarded as the ninth and furthest planet from the Sun, Pluto is the largest known dwarf planet in the solar system. The unusual world is situated in the Kuiper Belt, a region beyond Neptune's orbit which is teeming with 1 trillion or more comets and hundreds of thousands of stony, icy planets, each more than 62 miles 100 kilometers across. Pluto was downgraded to a dwarf planet in 2006, ending its status as a planet. This reclassification sparked debate and controversy among scientists and the general public. Percival Lowell, an American astronomer, first proposed the existence of Pluto in 1905 after noticing odd anomalies in the orbits of Neptune and Uranus. Lowell reasoned that these ice giants' orbits must be off because of another object whose gravity is pulling on them. Lowell went on to predict the location of the enigmatic planet in 1915, but he passed away 15 years before it was found. Based on predictions made by Lowell and other astronomers, Clyde Tombaugh eventually discovered Pluto in 1930 at the Lowell Observatory. Pluto is so far away from Earth that until 2015, when NASA's New Horizons space mission completed a close flyby of Pluto, little was known about the dwarf planet's size or surface conditions. Pluto has a diameter of 1,473 miles, 2,370 kilometers, less than 1/5 the diameter of Earth, and is only roughly 2/3 as wide as Earth's moon. On the other hand, recent computer simulations reveal how Pluto is fortunate to be in the orbit that it's in, as the dwarf planet skirts close to a chaotic orbit that might perhaps destroy the beloved world. The orbit of the old ninth planet is unusually inclined and lengthy in comparison to the orbits of the other planets. Pluto really moves inside Neptune's orbit for 20 years of its 248-year voyage around the Sun. Azimuthal libration and latitude libration, two features of Pluto's orbit, prevent them from ever colliding. When Pluto crosses Neptune's orbit, it's always at least 90 degrees distant from Neptune, a phenomenon known as azimuthal libration. Latitude libration, on the other hand, makes sure that Pluto is always far above both the plane of the solar system and Neptune or any other huge planets when it comes to being nearest to them. These two elements work together to protect Pluto from harm. Planetary scientist Takashi Ito of the National Astronomical Observatory of Japan and Reno Malhotra of the Lunar and Planetary Laboratory at the University of Arizona have now improved their understanding of Pluto's survival in this particular orbit. Because of the two planets' 3-to-2 orbital resonance, which states that Pluto orbits the Sun exactly twice for every 3 times Neptune orbits the Sun, researchers discovered that Neptune, predictably, has the most influence on Pluto's azimuthal libration. The models, however, imply that Neptune has little effect on Pluto's latitudinal libration. However, when you add Uranus's gravity to the equation, things start to go south because Uranus acts to undermine both azimuthal and latitudinal constraints. Only these two planets could have caused Pluto's orbit to become unstable after tens or hundreds of millions of years, which would have caused Pluto to either collide with Neptune or, more likely, be flung out of the solar system altogether. Pluto is saved by Jupiter and, to a lesser extent, Saturn. Although Neptune and Uranus are further away from Pluto, their gravity is so strong that they can still dominate. Jupiter alone exerts enough gravitational pull to maintain Pluto's orbit steady for at least 5 billion years, which is how long the simulations were run. The surprising aspect of this new research is how small Pluto's zone of stability is, and how the dwarf planet's only chance alignment with the solar system's other planets allowed it to exist. Unofficially referred to as Tombaugh Regio, a sizable heart-shaped patch on Pluto's surface is another distinctive feature. Carbon monoxide ice has covered the left side of the area, which has the appearance of an ice cream cone. Within Pluto's heart, more differences in the surface material's composition have been found. The New Horizons crew informally refers to a remarkably smooth area in the center left of Tombaugh Regio as Sputnik Planum in honor of the planet's first man-made satellite Sputnik. This portion of Pluto's surface doesn't have any craters left over from meteorite strikes, indicating that it isn't more than 100 million years old geologically. It's likely that geologic processes are still shaping and altering this region. A few kilometers long and oriented in the same direction, black streaks can also be seen on these icy fields. It's possible the lines are generated by fierce winds blowing across the dwarf planet's surface. Pluto's surface is one of the coldest regions in the solar system. Around minus 375 to minus 400 degrees Fahrenheit can be experienced here. Pluto appears to have gotten redder over time, possibly as a result of seasonal changes when compared to earlier images obtained of it by the Hubble Space Telescope. There is some evidence that Pluto may have had a subsurface ocean, but this is still up for debate. The existence of the subterranean water may have had a significant impact on Pluto's past. Scientists discovered, for instance, that the zone of Sputnik Planitia altered Pluto's orientation because of the area's large concentration of ice, which New Horizons calculated to be around 6 miles thick, 10 kilometers thick. However, looking at less plausible alternatives, the researchers noted that a subterranean ocean is the best explanation for the findings, although a thicker ice layer or changes in the rock may be to blame for the shift. Images of a region with 2 large mounds that scientists think are ice volcanoes are being looked at in a fresh research. The surface surrounding these mounds was probably produced by relatively recent activity of the ice volcanoes or cryovolcanoes, according to the study's findings. The discovery suggests that liquid water or something similar may still be flowing or may have recently flowed beneath Pluto's surface, and that these volcanoes may still be active. Additionally, recent activity suggests that Pluto's interior is likely warmer than previously thought. The scientists claim that their findings could potentially increase the likelihood that there is life beneath Pluto's surface given other recent discoveries. Photographs of a region dominated by the Wright Mons and Piccard Mons, 2 sizable mounds believed to be cryovolcanoes, were examined by the researchers. Compared to Piccard Mons, which is roughly 4 miles, 7 kilometers high, and 150 miles, 250 kilometers wide, Wright Mons is a mound that is 2.5 to 3 miles, 4 to 5 kilometers high, and about 90 miles, 150 kilometers wide. The peaks of the alleged ice volcanoes also have extraordinarily deep depressions. The Wright Mons depression is nearly as deep as the mound itself. The terrain also has a distinctive lumpy or hummocky appearance in several places, made up of undulating, spherical mounds. These 2 large mounds may have developed over time as a result of the accumulation of smaller ice volcano-formed mounds, according to the researchers. According to Kelsey Singer, a planetary scientist at the Southwest Research Institute in Boulder, Colorado, there were no other areas on Pluto that look like this region, and it's totally unique in the solar system. This region of Pluto features fewer or no impact craters than other regions, which suggests that the surface was produced relatively recently in geological time. The paucity of craters suggests that the region is only 1 or 2 billion years old, with certain regions possibly being as young as 200 million years. Cryovolcanoes resemble volcanoes on Earth in certain aspects because Pluto has a large portion of its surface covered in ice and because its temperatures are much below the freezing point of water. This implies that liquid water or something similar that is at least somewhat fluid or mobile would behave similarly to magma on Earth, rising to the surface following an eruption and solidifying or freezing. It's probably not coming up completely liquid. It's probably more like a slushy thing where you have some liquid and some ice, or it could even be more like a flowing solid. Singer said, which could be more like ketchup or silly putty. It could even be more solid ice that can still flow. We all know that ice can flow because we have glaciers that flow on Earth, she said. Cryovolcanic activity on Pluto is presumably driven by radiogenic heat produced by the disintegration of radioactive elements in the dwarf planet's interior, despite the fact that scientists don't fully understand how it might function. Pluto lacks plate tectonics, the intricate system of moving continental crust that underlies geologic activity on Earth. But a similar event is one of the sources of heat in the Earth's interior. General tectonics, which may still produce characteristics like faults in rock but lacks tectonic plates, is the term used by scientists to describe geologic activity like that on Pluto. The shield volcanoes on Earth, which are low-profile volcanoes formed by the slow buildup of lava flows into rounded structures, have several characteristics with Pluto's cryovolcanoes. Instead of thinking of an eruption like Mount St. Helens or Vesuvius, picture the volcanoes on the Hawaiian Islands. However, unlike what scientists believe occurred on Pluto, shield volcanoes often emerge from incredibly liquid lava. A caldera, which is a depression in the center of some volcanoes on Earth and other planets, is created when a newly erupted volcano collapses into the space left by all the debris it spewed forth. Even though Mauna Loa, a shield volcano in Hawaii, is one of the greatest volcanoes on Earth and has a relatively modest caldera, the two structures are similar in volume. The depression on Right Mons is so deep that the volcano would have had to lose almost half of its volume to be similar in shape. There is still a lot that is unknown about these structures, their formation, and Pluto's cryovolcanism. Given other research that suggests Pluto was hot when it first formed and may still have a liquid ocean beneath its icy surface, the idea that liquid water could exist beneath the surface of Pluto raises the chances of life existing on Pluto from practically non-existent to slightly more plausible. And scientists are interested in learning more about our own planet in addition to worlds outside of our solar system. Additionally, the other NASA solar system projects are really enhanced by the James Webb Space Telescope. With the aid of Webb's groundbreaking advances in sensitivity and resolution, data at various wavelengths and from many sources can assist us in constructing a more comprehensive picture of Pluto. Asteroids, comets, and Kuiper Belt objects will all be observed by the Webb telescope, in addition to Mars and the large planets, minor planets like Eris, and even the tiniest bodies in our solar system. Let us know what you think of this in the comments section below.